Wait a sec. If I'm doing programming, then that means I have to get another iPad to do it.
Yes. All right. So we're starting our programming class. So this is Scratch programming. And it would be good to start right from the beginning, which will only be appropriate. We can say Scratch programming is getting your character on stage. And here we call this character a sprite. Right? So that's a fancy name for an animal, an object, a person that you have on stage. We call that a sprite. Right? We spell that like that, sprite. And number two, you have your stage, and a fancy name for our stage is called backdrop, a backdrop. And then the third, we're gonna say is code. So these are the three elements of Scratch. So get a sprite, an object on your stage, okay? And that stage, we can also call it a backdrop. And then use code to bring that object to life. And how do you bring something to life? By doing some actions. Like it can move, it can spin around, it can speak, it can fly, it can swim, depending on what object you have on stage. So these are the three elements that we'll be using to describe what programming is all about. So what is programming? Or exactly what is Scratch programming? Get a sprite on stage and get it to do some action with codes. So let's look at these three elements: sprite, backdrop, and code. Okay, there we go. Number one, this is our cat. We can go full screen by clicking here. See where the mouse is? You click here, you go full screen, and there we go. We have the cat on stage. All right, and now let's come back to our programming environment. This is our programming environment. We see like this. And we can delete the cat right here. We can just click on this trash can icon. Click here and the cat is no more. So we have an empty stage. If we go full screen again, the stage is empty. We can remove whatever we have on the stage like that. The stage is empty. Let me bring that back up. Okay, and now let's see where we can get the cat again. And we call that our sprite library. Our sprite library. So we go to our sprite library here. You say choose a sprite. So when we click here, we'll go to the sprite library. And the sprite library is interesting. It has been divided into groups or categories. And here it says all. So here you can see everything. You can see everything. So we scroll down. We scroll down and their names are there. So we can read on. The names are there. If we double click on it, then we'll bring it on stage. So that's how to select. You even have letters. You even have numbers. So again, we have all these elements. But here, all these sprites, they have been categorized into groups. We have the animal group. It will only show you animals. So that's very good. Once you know you want to choose animal, you better come into animals rather than going all. You will not see all the animals in one spot. So you click that group. If you want people, a boy, girl, a man, a woman, grandpa, grandma, some other sports or fairy tale persons, you'll find them here. Fantasy, yes, like fairy tales. You have things like griffin, goblins, bat, a centaur, an elf, ghost. You have all that here. And then we go to dance. To dance, you can see dancing. Okay, these are like, you see, like this guy keeps changing. This champ 99 keeps changing. Those different pictures are called costumes. Those different pictures are called costumes. So we will talk about that. Music, you can see musical instruments. You can see what? musical instrument, and a singer. Another name for singer is vocalist. It's a vocalist because you have vocals. You use your vocal cords. You get voice out of your mouth. Vocalist. And here's sports pictures, and even sports tools like a ball. We have them there: the basketball, a baseball, a beach ball, soccer ball, tennis ball, soccer ball, or football. So we have food. So these are all sprites, and then you have fashion, right? Fashions like your clothes, right? Different clothes, like you have the dress here, and the dress also with different costume. You have a wizard hat, you have a scarf. What do you have here? Sure. What do you have here? Loudly. What do you have here? What do you have here? Glasses. And we even have letters. We can use letters to animate our names. And that's what we're gonna do today. One of the projects we're gonna do today. So that's it. And we'll come back. That's a sprite library. If we choose letter A, you see A here on the board. And we'll see A here also on the list. So when you select a character, you have it here where you can see the characters that are selected. So let's go back again one more time. Let's pick another character again, probably another letter, so that we can get ant. So we can get an N, and we go back there. We can get, again, we go to the category letter, and we get what? A T, because we want to use that to spell ant. So they're just there. When you bring something on stage, it's there. But then here, what do we see? We have A, N, and T. So when you get the characters or the sprites will be arranged here. So I want us to still talk about that, because we would look at something very special or interesting. It's called the properties of the sprite. Everybody? Well, in biology, we say traits. Traits is how something looks and how it behaves. So that's the traits. So trait, this is like you study biology, you're going to learn this word trait. But here, let's use another word called property. Property. Now, property, or there's another word called characteristics. Characteristics. So property is how something looks and how it behaves. So let's look at the basic properties that we'll see, but let's keep the word property because that is very important. It will go across our programming live. So the number one property, very important, is what? The size. The size. Number two, the color. And here we're spelling using American English. And number four, the shape. So things comes in all colors, sizes, and shapes. So everything you see around you, color, sizes, and shapes. Some are small, some are big, some are medium. Some are red, some are all types of colors. And then the shapes. Some are triangle, some are, oh, you should know these things. All right, so sizes, colors, and shapes. So those are some of the few. But here also, there's something called your position. Your position, right? Your position. Your position goes with your direction. So those are the properties. So if you have something on stage, where on stage? Because stage is not just a place there for you. Stage is a well arranged environment with positions of every dot you see on stage. It has a position. So like A is at a particular position, T is at a particular position, N is at, very good. So we have properties like that: size, color, shape, position, direction. What else do we have? We have its transparency, transparency. So transparency, if there's S, we're missing N's here, transparency. So here you will talk about the degree of transparency. If you can't see something, it's transparent. It means you can't see it. It is what? Transparent. You can't see it. And then if you can see something is really dark and clear, it is what? Opaque. It is what? Opaque. Yes, then in between you can say 50% transparent. All right? And then, so these are some of the few things, few properties that we see. But there are other properties, all right? So many properties. So it makes it interesting for you to know that a sprite, you bring a sprite on the stage, but you can change different aspect of that sprite. Now let's go to sprite A. Now once you have more than one sprite, you have to select sprite A and you have its shadow here. And this is the area where we code. We code in this area. We can bring code onto this area. So this area is the coding area. And when you see the shadow of a sprite, you know that that's a sprite that you are coding. We code sprite by sprite. You understand? Now we can code all the sprites together. We have to find a way to code all the sprites together by copying the code into each sprite. So we code sprite by sprite. So it's called, and another name for sprite is just object. So you say object coding. Object. Good. So we code object by object. So let's rumble. Now, so that's your T there, your N there, your A there. So let's focus on A. We select the A and we see the shadow of the A. Now let's go here. Under here, we have some few properties, right? Now this one says size. If you can't see it very well, this one says size, and then it says 100, all right? So we go to that 100 and we'll try to change it to 300. And then we'll press enter. So we'll click there and we'll type 300 from our keyboard and we'll press enter. What has happened to A? A has become bigger or increased in size. All right, so let's keep doing that again one more time. Let's change that to 5 and let's see what will happen to the A. Where's the A? Is that small or tiny? You use appropriate word. A becomes tiny. So you see that's the A. If we go full screen, the A now is small with respect to this. So how does the size work? Now the size takes the original size and call the original size 100. So this 100 just means 1, the full size. So the 100 here means 100%. Everybody? 100%. So we know what percentages are. A percent means the full, 100% means the full. So percent means over 100. So a percent, so if you say 100%, we have to do 100. And the percent symbol, this is a percent. Let me drink some water.
A is massive. A is massive.
So the percent symbol has this bar here. It means something over something. So the percent symbol just means over 100. So it means 100 hundredths. So which just means what? What's the answer of 100 divided by 100? It's just 1. So it means the full image, or the original size. Everybody say original size. Glory.
Original size.
Original size. Original size. And when you say reset size, it means go to the original size. Say reset size. Everybody say reset. Reset size. So when you set it to 300, then you reset. It means you go back to the original size. So we reset the size. So the size, when we reset the size, where do we go? We go to how many percent? 100%. Very good. Which means the full size, just one. Your percent just means over 100. So if they give you anything, change it to percent, it just means over 100. So if you say 2.5%, what is it? Somebody said 2.5%. You see a decimal there, you see percent. There's no problem. Put your 2.5, and then percent means over 100. And then you multiply by 10, you have 25. And down also you multiply by 10, you have what? 1,000. So
1,000.
and then 25 goes there once. 25 goes into 1,000 40 times. So that's how you can change 2.5% to fraction. So again, let's come back here. You see our properties. We have our properties. We just went off to math. But let's come back here. Size, color, shape, position, direction, transparency, all that. So let's get A to be transparent. Let's make A to be transparent. We just go here and click this. Where's A? A is still at this position. You see, we can tell A to move. For example, let me bring move here, move 100 steps. So A was here, right?
Mommy, where is A?
That's A. Where did I click? I click here. And this is where we see the transparent. It says show or hide. Show or hide. I'm not speaking. I don't want to miss in my class. Show or hide. So when we say hide, A is no more. And when we click on show, A will be there. So look at A is almost here. Let me put A here closer to T. Okay. Now if I say hide, A is still there. It's just transparent. Transparent means what? You can see through it. You can't see it anymore. It's totally transparent. Okay, so now like a glass. Yeah. Like that window there, it's transparent. Yes. Sometimes you can even think that there's no glass there, but it's transparent. So let's move A 100 steps. 100, another 100. Now, if we show A, do you think A will still be here? You see?
No.
A is now further this way. So bring A again, look at it, hide it, okay, then move it twice like that, show A somewhere there. So that's how we can use this property of transparency, and we can program an action of disappear and appear somewhere. You see? So you are using the properties of this sprite to create your games, to create interesting games. So if you know that, oh, I can go there and take a sprite, I can just go to the sprite library and take a sprite, but you don't know that sprites, they have properties, then you will not know how to make any interesting games. Because games are just programming what? Properties of sprites and then getting them to do some actions. So if I want somebody to grow, if I want a sprite like A to grow, I say, okay, first, maybe I make it very smaller. I make it very small, like in the beginning, I just say 20% of it. So that's A here, 20%. Then I will move it. I will first hide it, and then I move it. You see, I move it, and then I come back and I increase the size to 500, and then I press enter, but you can't see it. And then I show it. It's now big. So, and people be like, wow, where did it come from? So all these things that we are testing here with these properties, we can also use code, because now we have not gone to code. We are just learning what? Sprites and their properties. Sprite and their properties. So 500%, let's come back, let's reset, means we go back to what? 100%. So that's our A there. So to just stay here and look at properties of Sprite is very important to give us a complete understanding of one of three things about Scratch programming. The three things are your Sprite, your backdrop, and your codes. The three things are
The web and code.
Sprite are your characters, your objects that you bring on stage. The stage is your backdrop, and your code is what puts everything together. It brings the whole thing to life using codes. Codes are the actions that your backdrop and your sprite will undergo. They will undergo several actions. Now, let's complete the sprite knowledge. So let's hide our N. We hide it. We make it transparent. We make our T also transparent. So what do we have on stage? We have A. Now let's look at the position of A. So let's go here. We have X position and Y position. So that's another property. Now to better know your position, there's a backdrop, but I won't go to that backdrop yet. I will just teach. X equals 0 and Y equals 0. And that will be your center, So you want to think of it like we take X means the left, right direction. So we say from the center going left, these are negative. From the center going right, these are positive. So, and your left, right direction means we just use a name for left, right direction. We call it X. We call it X. And then now, what about the up-down direction? Our up-down direction, we call it Y. Moving up is positive, and moving down is what? Glory. Moving down, up is positive, moving down is what, Glory?
Moving down is
negative. Moving up is positive. And this up-down direction, we call it Y. We give it a letter. So if you look here closely, you will see that letter. Here it says X. And you see this arrow here, it means left, right direction. Here it says Y. Look at this arrow here, it says what? Up, down direction. So left, right direction is X. Give it letter X. So remember this. And up, down direction, we give it letter what? Letter Y. So remember that. So it's just two letters that they have chosen. They can use A or B. A for left, right, and but here they've just used X or Y. So again, understand that every time you say change X, because you will have in the code, we'll have things like change X, you see, like this, change X by 10, or we can put negative here, change X by negative 10. So you see, if I say negative 10, it's moving where? To the left. If I say positive 10, it's moving where? To the right. So again, X is your left, right direction. And then you see that X is changing. X is now 30. We want to bring it back to 0. I will be removing 10. Remove 10 is 20 now. X is 20, you see? Remove again, X is 10. Remove, X is now 0. We can go to Y. We can also have change Y. Change Y, where will it go? Change Y by 10, where will it go? Did we say negative 10 or positive 10? So where will it go? Up. Then if we go behind this 10 and we put negative, where will it go? We go down. So because negative y is down positions. So we can also say change by 60. 60 will make bigger steps. See? Yes. And then here we can say change by negative 10 so that we go back to that 0. Now we are back at 0, 0. So again, position is very important. Then there's something that says go to random. Now, what's the meaning of random? So random means any. Random means what? Any. And the word any means you don't know it. If I say give me any book, I don't know which book you will give me, right? So when you say random, it means any. So go to any position. So when you click this random, go to random position. Yeah, you see it is going to positions that we don't know. Where will it go? Up, down, left, center. You see, you did not know that was down. Where will it go next? Guess. You guess correctly. Guess. Left, right, up, down. Left, correct. Left, but down. Where will it go now? No. Where will it go now? Right. Some people, right wins. Where will it go now? Glory. Where will it go?
Left.
Left. No, he went right. Where will it go now? It's still there. So this is the meaning of random position. You never know. So you can use this go to random position to make a game, to make a guessing game. And how will you make a guessing game with this? If A here is what? X position is 135. So if you go more than 135, it will mean right. So when somebody says right, we have to check if the X position of the final place is more than the previous X position. Are you understanding logic? To make games very easy. We'll be using position to make games. If you want to say somebody guess that you will go up, okay, who controls up and down movement? Which position controls up and down movement? Y. Why is the up and down movement? So how can we determine that A has gone up? The new Y position should be what? Higher than the previous Y position. And the previous Y position is what here? Negative 108. So the next Y position, if we go random, should be higher than that. For example, good. Now it's 73. 73 is higher than negative 108. So I have to store the previous Y position. Then I make my guess. And then my guess will be yes or no, or correct or incorrect. If I take the new Y position, I compare it with the previous Y position. And now that is the kind of codes that I'll be writing. Then I'll be showing your answer yes or no. So again, understanding the properties of your sprite can help you build different kinds of games. If you don't understand it, then you are not ready for Scratch programming. All right, so Glory, your Y is your up and down position. You can use it to build games like guessing game. Will it go up or will it go down? We'll only be looking at Y. We'll not look at X. Now, X can help you build what type of game? Left or right? Will it go left or will it go right? You'll be comparing.
Uncle Daddy.
Yes.
Some of the games that I made, they just disappeared. I was gonna show you.
Well, you are programming online, right?
No, since we're doing programming, I'm programming on the other iPad. I'm using what you're doing.
But are you not going to MIT, are you not going to scratch.mit.edu?
Yes, that's what I'm on.
So that is online. So you are using online, you are using the internet to program. So anything that you make will disappear except you save it to your account. Daddy has to sign in using an email, and then you can save your games online and they will not disappear. Now everything you make will disappear when you come the next time. It would have been gone. Do you understand now?
Yes.
Daddy has to use his email to create you an account so that you can store it online like we do our electronic mails. All right, let's continue. So A is there. We can't see our end because we made them transparent. So we've understood what positions are. Now let's go to direction. What is direction? Direction is, even though A, we say what's the direction of A? Direction of A is 90. Now, direction is like all your sprites, they have a face. So the face of A, this is the face of A, this side. This is its face. So it is facing this way. Now, let me do something little just to show you. This is A. Okay, I can come to costume and then I want to add here the direction of A. So this direction is the direction of A. Let me just put an arrow like this. It will stick on the A. It will just stick on A. So that's the direction of A. Good. Just for me to demonstrate that. So A is facing that direction. So see how we can change the direction. You click here. You see how that pointing is changing? You see how it's changing? So that's the meaning of direction. Direction is a good property. So if you say that direction and you come and say move, it will move towards its direction. You see? That's the meaning of direction. If you change direction like this, you say move, it will move towards the direction. If you change the direction to be this way and you say move, it will move towards the direction. So the move code moves towards direction. So that's why direction is very important. Sometimes you move it, why is it going by this way? Especially when the direction is like 90. Look at 90. Direction is 90 and you say move. See where it's moving. You say move, it's moving this way. But now I'll put a direction negative 90, and see where it's moving this way. But it turned upside down because it has turned like this, and then it's facing that way. But if we say, okay, go back to 90, but when I say turn, don't turn all around. This one says all around. Just do what? Left, right. And then this one says do not rotate. So if we choose the left, right, and then we say negative 90, see what's going to happen now. The arrow was pointing that way. Now it's pointing this way. And if you say move, but if I did not put this arrow there, it will still look like the A. And you will not know where the A is moving. So for example, I go back to costume, I use select, I select this new thing that I added, I delete it. So now we are moving this way. And then now we go back to 90, and now we are moving what? That way. See? So if you don't really master direction, then you'll be like a little bit confused. But what is your full turn? When you turn full turn is what? Be loud, young man. Nobody can even hear you online. We are recording this thing online. It's like you people don't want to use your voice. If I'm speaking like you people like this, would Glory hear me? How should I be repeating myself to you people all the time? People, you get me angry, I will just send you people out. I just have one student that can be loud here. Every time they'll tell people to be. So when you face up is what? 0 degrees. When you face this way, it will be what?
0 degrees.
90 degrees when you face right.
90 degrees.
So it means when you face up, and then you turn from facing up, and you come and you're facing right, we call that 90 degrees. So if you face right and you come and face down, that is another 90 degrees. So altogether will be what?
180 degrees.
180 degrees. So 180 degrees is called,
180
it's called turn
degrees.
around. It's a turn around, a turn. So if you are facing front, if you're facing up, you turn around, you're facing down, that is 180 degrees. If you are facing right, you turn around, you're facing left, that is what? 180 degrees. Now you come and you turn, you are facing 0, you turn 90, you turn 180. Then if you turn this way, you'll be what?
Minus 90. Minus 90.
You'll be 270. Because
What?
you are adding another 90. We are turning like this. Glory, you have turned like this. You add all the turns. You have turned like this right up to here. So you have turned 270. Then if you continue turning, and you go back to 0, you have turned what? 360. Because we were turning clockwise. Now, Glory, let's come now and turn anti-clockwise. If you turn here now, it's the negative turn. You turn now and you come to this. You have turned what? Negative 90. Because you're turning anti-clockwise. Glory, say anti-clockwise.
Anti-clockwise.
Anti-clockwise. And then
I've heard about it in grade 2 in school.
And then when you turn this way, it will be what? Negative 180. Negative 180. And when you turn, you come this way, it will be what? 270. Negative 270.
70.
And then when you turn, you come this way, it will be what? Negative 360. Negative 360. And then when you continue again, negative 360 and turn and come back again, negative 720. You have made another 360 again. So turning, you can turn 1 round, you turn 2 rounds, you turn 3 rounds, you turn 4 rounds. So to capture the rounds, we'll be adding more 360s like that. And when we want to show that on a line of direction and something, when you plot a curve, direction and something, this will be 0 degrees. If you turn the clockwise, you turn 1 round, it will be what? 360, like this. If you turn 2 rounds, it will be what? Another 360 will be what? 720. But if you turn anti-clockwise and you turn 1 round, it will be what? Negative 360. And if you turn 2 rounds, anti-clockwise will be what? Negative 720. So if you want to stretch your direction, even though you are turning like this, but you want to plot your direction on a graph, your direction now will be like on the direction axis, and you can call that direction axis theta. You can call it what? Theta. We can use a symbol, not X, because X is left, right. So this one we call it theta. And theta is an alphabet, but it is not the English alphabet. It is the Greek alphabet. Theta. Theta is a Greek alphabet. Picture time. You want to go to picture time to see that symbol theta? All right, let's go to picture time and see theta. So go to Bing and we put Greek alphabet. Greek. Laurie, can you see? Laurie. Laurie, you're not answering. So we go images and we see the Greek alphabet. I want to show us the big and the small. So we can tell where we have the big and the small. Let's take this one. We're already seeing it here. So English, we have A, B, C, D, E, F. The Greek alphabet. The Greek alphabet, we have alpha, beta, gamma, delta, epsilon, zeta, eta, theta. So that's the theta here. Okay, we'll see the names here. Everybody read. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta. So that's the theta here, small symbol. And iota, kappa, lambda, mu, nu, chi, omicron, pi. Who has seen pi before? Pi is letter P in the Greek alphabet. Rho, sigma, tau, epsilon, phi, chi, say chi, psi, or C, and omega. Have you ever heard of alpha and omega? Did you know that alpha and omega means the beginning of the Greek alphabet and the end, like the A to Z? When you say God is the alpha and omega, you say God is the A to Z. Huh? Who is learning this for the first time? Do you know that this is the Greek alphabet? Omega. Did you know the Greek alphabet, the complete Greek alphabet before? So this is a Greek alphabet. A lot of letters that we use in mathematics is taken from the Greek alphabet because we already use the English alphabet to spell. So they don't want us to confuse some symbols. So they better use the Greek alphabet. Glory, are you there?
Yes.
You know your Greek alphabet, Glory, do you?
What's a Greek alphabet?
Is the writing of people from Greece. Greece is a country. That was the birthplace of the Olympic Games in Greece. One city in Greece is called Athens. Athens. It's a city in Greece. And Greece is in Europe. You are not far from Greece. You are in the UK. All right. So we were talking about direct. So we have seen our directions. And we can use theta or alpha to mean a direction. So another name for direction is what? Angles. Another name for direction is what? Angles. The angle that you're pointing at. So again, we have seen that. Or turns. To make direction, we turn, right? We don't just move left, right. We turn. We don't move up, down like the positions. For positions, we move left, right, or up, down. For direction, we do what? We turn, but we stay in the same position. So see this position of A. Position of A is negative 23 and 39. Let's change the position to 0, 0. We change it to 0, 0. But now let's turn the direction. As we are turning, see, A has turned. See. Okay. A is turning here, but it's not turning. Why? Because in the left, right. Because we say left, right, direct. If we say all around, see what now? It turns now. See? But A now, direction is negative 124. But where is the position? 0, 0. Still what? 0, 0. It turns here. What's the position? 0, 0. So you are turning about a position. It's like Angel's feet is still at the same place. And now Angel is turning his body. See? It's turning where you are facing. Your feet is still the same position. So your position does not change, but your direction changes. Glory, position does not change, but direction Changes. All right. So we have seen the property, and we can also use direction to make so many games. I'm finding somebody. I look this way, I don't see him. I turn, I go this way. I turn, I go this way. So we have codes for that. When they say turn 15, and when we turn 360, but what is the name of that unit? 360 what? Matabo? 360 what? Degrees. So each of that turn is called a degree. And altogether, to make one complete turn, we are breaking those turns into. So who knows what 1 degree is? 1 degree is very easy. You see, 1 degree, we're going to go back, picture time. Everybody say picture time.
Picture time.
No glow.
Yes, definitely.
You are sleeping on me. I said picture time and you didn't say anything. 360 degrees protractor. So that let's see what turn actually means. Which one do we use here? Good. Let's use this half one for 180 first. So when you start from 0, you see you can start from 0, you go the inner ones from 0 to what? 180. Or you can use the outer scale from 0 also to 180. Now, see, this is 0, this is 1 degree, 2 degrees, 3 degrees, 4 degrees, 5 degrees, 6 degrees, 7 degrees, 8 degrees, 9 degrees, 10 degrees. What do they mean by that? In fact, who is taking here? In fact, this is what they mean by that. I'll bring my. Now, your leg was here. And if you point here, you are at 0 degrees. Now, you instead of pointing there, you go and point here. Now, you've gone 1D. Now, you are pointing, but this direction is what? 2D. You are pointing this direction is what? You are pointing here 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 is what? 28 degrees. And you are pointing this way is what? 110. And you add here 115 degrees in this direction. But from this side is what? 65 degrees. You see? From this 0 here, 65. But from this side, 115. You see why a protractor has 2 blades? You say you started from this way. If you go like this, it is 65 degrees. If you started this way and you come like this, it's 115 degrees. Understood? So degrees is about what? Turns. Degrees about what? Turns. It's not about position. So if you keep that, what about now a short line? Now you see a short person can start from here also. He's pointing here. And he also turns and now he's pointing this way. Both of them are pointing the same direction. So both of them have turned. They have turned what? 115 degrees. But they are different positions. You see, it is about what? The turns. It's about what? The turns. Not about where we are. So direction is very different from position. Very good. Glory, understood? Glory, you're muted. All right, so we have seen directions. So I think by now we understand those different properties of our sprite A. Now, what other properties do we have that we can't see here? Here we have seen transparency, show or hide. We have seen its name, right? We say block A, so that's the name. The name of something is also its property, right? I have a name, I have a size, I have a shape, I have a color. So my name is one of my properties. So we have seen the name, and then we've seen size. We can control size from here. We have seen direction. We can bring it back all around direction. We can bring it back to 90. Okay. But if we put like 0, you see that we'll be facing up of like our 0 degrees. Position 0, 0 and facing 0 degree, that is up. So we have seen size. What we have not seen is what we're going to look at right now. Now, we'll make another video on backdrops, but we are still talking about sprites. We're still talking about what? Sprites. Now let's change our size to 200 so that at least the A is big enough for us to see. Now, what about its color? Color is also another word. Property. What about its shape? Shape is also another word. Very good. We have seen size. We have not seen color and shape. So for color and shape, code has to help us. So when we go to the code, we have categories: motion, looks, sound, events, control, sensing, operators, variables, and my blocks. Now we'll learn all of these under codes. But for now, we want to look at properties that we cannot get from the property pane here. This is a property pane. This is a little section, the property section or pane. When we come to the windows of a computer, we say this is our pane, like the window pane. Pane is just that frame like that. So this is a property pane. Very good. Now let me show that for anybody that's watching and learning with us. Your property pane is what we have here. That's where we can find some easy properties here. It's a property pane, right? So when you select something like A, then you can change some properties about A here. But not all properties about A are found here. So if we can't find them, we go to the section called looks. Everybody say looks. So like the name states, that's the name of all these codes of this purple color. All these purple color codes are called looks. Now from looks, we can still see size. We can come there and change size. Here we can set our size in the very beginning of any of our programming. We say set size to 100%. If we click it, that is 100%. And we can go back to our 200% just by changing 200 and we click. We are 200, we can change to 600 and we click, we are at 600. We can change to 2, but the smallest size will be 5. No, it says 8. For this one, it says 8. So the smallest size for this one is 8. Depending on the character, the smallest size can never be 0, right? Because if it's 0, there's no point. You can't see it again, right? So again, or if you really want it to be 0, what do? Transparent, right? Disappears. Yeah, so we have ways of making 0. Okay, so now let's bring it back to our 200 and hit it. So we can set size. We can also use change size. So this is how we can manipulate this thing. We can set a size, change size by 10. What does it mean to change size by 10? Add 10% to the size. So if the size was 100, if you click this one, the size will go to what? 110%. You see? If we click again, it will go to what? 120. So we can use this to grow, to give the idea that something is growing. We can add some sound there, see? We can make games with that. So you see, when we go to looks, we can looks can help us, give us some codes to help us further manipulate the properties of the sprite. So that's change size. We have already seen change size. We can change it here, but once we learn how to change it by code, we'll not be coming here and be changing and be typing, right? We'll just do what? We'll just change by code. For example, if I want this thing to grow, I can just bring a code that says repeat 10 times and then go to change size by -10. But since the computer is too fast, it's going to do it very fast. It has done all the 10 times. If I say 100, repeat 100 times. You see? So it gives a cool, because now we are using control. You control how many times you want to repeat. You make loops. You make repetition of this same code. We repeat this code 100 times. So we'll go right to the smallest size. Now, if we do positive 10, and we still do this one, it's going to grow right up to the largest size. 100 times 10 will be 1,000, right? But it will not go to one. It will not get to 1,000. It got to 681. So once it's already full screen, it says if it goes any larger, it's going to be too big that you cannot even see it again. But is it possible to go more than this 681 for this A? Yes, it's possible. But we have to look at that gymnastics later. All right. So again, we are here. So let's look at color. Do we have anything like color here for code? Yes. It says change color by 25 what? 25%. At least you can say degrees. Lord, Jesus. People learn, eh? So set size. This is 681 what? Percent, meaning that it is 6.81 times its original size. This is 6.81 times. 681 means what? 600 means what? 6 times. Because 1 time is 100%. 2 times is what? So again, I said 2 is what? 200 what? Percent loudly so that people can hear you. Oh my God. Like in Moreri, like if I say, okay, I'm going out, sit here and come and teach. You should be able to just come and sit here and teach because we have been talking. Eh? Loudly. Yes, sir. See, the voice is not coming out because you have not been using it. All right. Now, this is change color effect also by 25%. But how does it work? Look at this purple. Look at this orange. If you say change color by 25%, see the color. So if you start from the original color, then let me go back. Change color by what? Negative 25%. Where do you think will come? Where we started. So if you add 25% of this color, it will go to the other color range. But where do we actually see those color range? Let's go here to costume and click here. This is a color range. You see? From this color right up to this other color. So you see that's the range. And then comes back to this one. You see that ending here and this ending here almost the same, right? So that's how color goes round on the spectrum. And this is something that you need to know. If we change color by percentage, it goes from one extreme color to the other. But if your thing is pure black, for example, I go here, I make this thing pure black. You see? I make it pure black. Yes. You know that when you go to costume, you can change things. Costume is like your painter. You can go there and paint. So when we come here and we say change by 25, negative 25%, you see, it's changing, but not too much, right? Because it is dark. It is changing with that darkness. 25% of that darkness is still not that light. It will not be too light. So again, it depends on if you have your bright color, then you can see all the different spectrum things. So it is actually changing, but that darkness that you gave it is really affecting it. Now let's go back to costume and bring a brighter color. Okay, let's give it this one like that. Good. We do a brighter color like this. So you see, but it did not show the green here. Why? Because we had already changed it with effects, right? So if you go, you see now you can see different bright colors now. See different bright colors. But then you are not seeing a lot of colors. So now if you go say just change by 1%, and then we go and to control and say repeat 100 times. Oh, we said 10. 100. We repeat 100 times. Are you seeing the changes? Repeat 100 times. Okay. Now, but if you say 5 and repeat 100 times, then each time they repeat, you want to wait so that you see a little bit. But we'll not wait too long. We'll just wait 0.1 seconds so that you see. Okay. So again, you can also use this one in your programs where letters are going. You can use all your letters. And as it's moving, it's also dancing. It's also dancing. For example, if I just go there and say, okay, as you are changing like this, be also moving like 2%, right? 2 degrees, right? And I do that. Colors changing, turning around, colors changing, turning around, colors changing, around, colors changing. But what are we using here? It's just color and direction. What are we using? See, you made me waste my time to ask that question twice because you did not repeat. And you wonder why I'm teaching the very little kids. I've made moral education for kids, any education, little. Because when you say repeat after me, kids, they will repeat every time. People will forget. So programming is about mastering the properties of your sprites. Mastering what?
Properties of your sprites.
And now, just now imagine what you can imagine. Then once we go and we learn the different section of your codes, then you will know that, okay, if I want to repeat, if I want to change a property and I want to do it 100 times, I can go to control and I take repeat this action 100 times, 200 times, 10,000 times, or I can repeat it forever. I'll go to control. I will not, if I want to repeat it forever, I'll take but forever. So forever will be the one coming there. If I do forever like this, it will never stop. Yes, we do this forever. So again, if I don't want, I just stop everything and move. So we have seen colors. We have seen colors. So to delete all these things, you carry it and just dump it here. It disappears. So what about shapes? We have not seen shapes. Now inside this color, we see this drop down
arrow.
So we click on this drop down arrow. We have so many other properties that we can change. We have brightness. Brightness by 25%. Too bright. And when something becomes too bright, it's like pointing a torch, a flashlight to your face. It blinds you. It's still there, but too bright. Now it's becoming too dark. We are reducing the brightness. So that's another property, brightness. Then I say, but which one is the normal brightness? No problem. You come here and you say what? Clear graphic effects. Clear graphic effects. When you clear, for example, when we do bright, and then if you clear, it comes back. That's the number. So what else can we change? We can change pixelate. Pixelate. What is pixelate? Picture time. What is
Pixelate.
Picture time or no picture time? You can still explain pixelate by. Yes.
Yesterday, I found out that you don't need a computer to go on the playground thing on Kids A to Z.
So, wow, what do you need?
You just need to have the app Safari.
Yes.
And you search, then press the blue X.
Yeah, you can go on Kids A to Z on Safari too. So pixelate is how to learn how the computer screen works. The computer screen is a small triangle where you can just color in. So to make a butterfly, You make a small triangle that way. You can only, all the whole triangle, you can only put one color there. But if you make a triangle smaller and smaller, smaller and smaller, you have this our full screen. That looks so clear. But the very, very first screen in those days, they were like this, yes or no? Have you seen those Walkman? Walkman, when people were playing games? Yes, they look like this, right? So these are called pixels. These are very large pixels. Pixels, just those small places for dots. And now,
I mean pizzas.
when we reduce it, at least it looks better like this. Look at like this one. This one looks better now because the pixels. But anyways, it's not like it looks better too, but it's just that the colors are not that many. So you see, like it cannot have a smooth, round head because the pixels are this size. You see. So, but when you reduce until you cannot even see that small square, then it will look like it is smooth. So once you learn what pixel is, pixel means picture element. Pixel is a short for picture element, meaning that a small square where you can only put one color. And that is how this computer screen is made up of. And then now let's see how many small of these small things are on the computer. So when we go to about this, we go to system preference. When I come to system preference, I can come here and I go to display.
And then you pause the board.
I pause the board. Sorry, I will show your friend something. I'm coming back. So we go to
And Uncle Nanny, I have one of those games.
Go to display to
that I can color in the squares.
Color.
I have one of those games anyways. Mm-hmm.
Built-in resume. Let me go back.
Games.
So I wanted to show you people a display.
Uncle Nanny, I can't see it.
Yes, I really need to find it first before I show you. Why is it not here? Display. Yeah, they should be in display. Scale. Good. Yeah, scale. You see 160 times 90 that by 900. What do you think that means? Let me get it so that Glory can also.
Can I show you something on my iPad?
Glory, am I not trying to show you something here?
Yes, but it's the same thing.
Let me show you my whiteboard. Can you see my whiteboard?
Yes, looks pretty squarey.
Okay, so this is what I want to show you. Can you see this one here?
Yes.
So 1080 pixel. Can you see it? 1080 pixel.
Yes. What?
Oh, you are seeing by this one.
What? I'm gonna zoom in. I can literally see the pixels because I'm zooming in.
Okay, you see, I've changed the pixel. It has changed size, right? So it means that it has arranged it into 1,600 times 900. So this length is 1,600 for the different cuts. Here is 900. So altogether, 1,600 times 900, it will give you the number of smaller squares. So if I change to this one, it will change, the screen again has changed. So that's a picture element that is changing like that. All right, so let's come back.
Uncle Nanny, now can I show you the thing I wanted to show you?
Yeah, show me fast, hurry up.
I have some maps that you can like pick pictures with those squares.
Very good. So those are pixelated. Laurie said pixelated pictures. Pixelated. So those are pixelated. They're drawn with pixels. They're drawn with like bigger pixels, those are pixelated. So I want us to come back here and pixelate this thing so that we can really see it. And with there, we can imagine what life could have been if we did not have better computers. So let's pixelate this one by 25%. By 50% now.
I even colored the
5%.
pizza.
Now let's reduce the size so that we see. Let's see if it actually looks like A anymore.
Like A.
Now let's clear the graphics. We come back to the A. Let's go to 300% for the size. Good. Then now let's pixelate by, it's too far. Let's pixelate by 5%. Okay, let's go. You see? That's 5%. Can you see that the edges are rough a little bit? You can still see A.
Whoa.
You can still see A. You can still see A.
It's amazing.
You can still imagine that it's A. Yes, it can still look like A. Now it's looking like some, you have to pass, it looks like A little bit again. But still not bad. Still not bad. But if you follow the grid, now you don't know that it's A. So you see that the pixels now are very huge. These squares, the squares are very big now. You see, the squares are getting bigger and bigger. Squares that you use for colors are getting bigger and bigger. And then here, how many squares? The whole picture is what? 1, 2, 3, 4, 5, 6, 7 squares.
This is surely big.
So imagine the whole computer was just made by these big boxes. So to write something, you just have to put a light, put a light, put a light, and then it will not even be, it will be like this, then another one like this. So to make A with a very huge pixel, it will be very difficult because if you want to make A, you can only use those boxes. A will be like this. This is the size of the box. You can only make A like this. Then here, make another one.
Yours is actually better.
And then what do you do in the middle? Do like this. And then you go down.
You just have to make those silly. Is that it?
So, then how do you even write your name on the screen? How do you write your name on the screen? The screen will be looking so ugly. So the pixels here, once you master what pixels are, then you can now see how many pixels do we have on this screen here. The length here is 480 pixels, and up down here is 360. So altogether, you can calculate how many boxes are there. 480 times 360, how many boxes? 480 times 360. There are 172,800 small pixels in this scratch box so that you can see things clearer on it. So
looks funny.
He who masters pixels masters how the computer screen is, or how the computer screen works. You'll be coming back to your original thing. From the original. From the original, if you change by -5, where do you go? Positive 5. And the other side also gets messed up. So what does it mean for you to pixelate in both direction? Yes, it does not make any sense. So pixelation does not have what? Positive or negative. Either direction that you go. Once you go this direction, if you want to come back, you come back in the reverse direction. If you go this direction, if you want to come back, you come back in the reverse direction. So here it does not have like a negative effect or positive effect. Then you clear graphics, then we are there. Then beside pixelation, what else do we have? Fish eye. You can make a fish eye. Let's say we make a
Fish eye. Fish eye.
See the fish eye?
It's so fun. Fish eye.
So
Fish eye.
pixelation is changing the shape. Fish eye is also changing the shape, right? So an A like this looks nicer. Right? Then clear graphics, we're back. Then let's say you go -45. So instead of going that way, you are coming the inside.
Let's listen at it. Fish eye. Fish eye. It's like an inflatable balloon. We're just getting air. Lots of air.
So you can make an A, so you can start your game and you make fish eye to like -100, and then from this one, people don't see that it's A. Then from here, you can come back like you are coming back from sleep. Hey, I'm coming back from sleep. Bam, I'm now here.
Make it fat. Make it fat.
I'm a frog.
They look so ridiculous.
All right, so that's fish eye. What else do we have? Whirl. Whirl also is good. Whirl is good. Let's whirl.
Whirl. It's like it's doing it. Twirl, 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 twirl. Look at A. Look at A. It's twirling so much.
So that is that. All this can change the shape. Mosaic. What is mosaic? Many A's. So just do 5 in a mosaic. 5 A's.
So good. Amazing. What? Did you really make that? 100 A's.
So right now, what about ghost?
Yeah, ghost.
Hey, you can't see me. Can't see me. Can't see me. You ghosted.
What? How can I take it back? If it's a ghost, how can't you see it? You can see through it, but
Hey,
not
I'm coming
on
back.
the computer. To real life. Better.
All right, so here in this change color, you have fish eye, whirl, pixelate, mosaic, brightness, and that. So those are the additional properties of your sprite. So that brings us to the end of the, what else can we do? Next backdrop. Okay, next costume. Good. Costume is also a very good property. Let's see if we have costume. We don't have costume. So when you get a sprite like that, you click here, it says costume. So we only have A. But now I can make different A's. Les différents habits. People are the A. So we can come here, duplicate, and we get a new one. And then I click this new one now. I go and change the color here to this color. And I put a color like this. So now we have two costumes. We have two costumes. You can go from one to the other. Then now I duplicate again. I have another one. And this time I want to change by the shape. I use this shape changer. This one like this is a shape changer. I put here. Then I drag this guy coming out like this. And then now we have three costumes. So this guy is trying to run away. So now these are three different costumes. If I go to code and I bring next costume and I click it, you see, it looks like A now is a person that's doing magic. And that is only possible because of costume. You see, I can go like, shoo, then I come back. But then I can also say, hey, switch costume. I want to only switch. And the costumes, they have name. This costume is called block A. This costume is called block A2. This costume is called block A3. So now if I just want to switch between block A2 and then A3, so A2 gives out the body, but I don't want to come back to this. I only want to do these two. So I go to code, I do only switch block 2, and then I duplicate. Duplicate is very good, means make the other one. So I go here. So if I click here, then I will come back. So here you have to put like a small weight in the middle. So I do, see, like switch to this, switch to this, I give it up. So like that you create, see your letter is creating what? Magic. Your letter is creating magic, you see. So this costume is what makes things to talk. For example, if I create a costume like this, you can create your own costume. Instead of doing choose a sprite, you do what? Paint a sprite. Now, if you come here and you paint your own sprite, for example, I can use this. I paint a sprite like this. I change the color. I give it a mouth. I change the color if I want to give mouth. So I give a mouth that is closed, you see. And I come here, I put duplicate, and I get another one. Then I give a mouth that is open. Okay. And then I take that first one again, I duplicate, and I give this one a mouth that is not too, that's just about to be opened. So now, if I go to next costume, and people who have been watching Ten Ten, this is how Ten Tens they talk. Huh? Is this not how they talk? Your cartoons. Is this not how your cartoons talk? So now, and somebody will say, that cartoon is alive. When you watch them, you say they are alive. Now you know that you make them from what? Costumes. That's all. Very simple like that. You make from costumes. So now you will not believe that those Ten Tens are alive.
Uncle Nelly, how did you add it?
Glory, you say, how can we add what?
Uncle Nelly, how did you add it?
How did I add that? I come here to choose a sprite. And you paint. You click there and paint a new sprite. So if you paint a new sprite, you can use a rectangle tool, or you can use this tool. Either you just put an outline, and then you choose a border, and then you choose a border size, and then we can make our own like that. Then here we can just go and hide this one so that we have this new one that we are trying to make. and it's this one, select it. And then we come here, we give it a small mouth. You can just put like, now he's not talking, like this, and his eyes, 2 eyes. So here, when you know how to draw, these things now becomes easy. Then from here now, you just duplicate. The second one now, you can go and give it a mouth. You can select 2, select this, delete, then bring like a small mouth. Bring like a small mouth like this. Or just make him like he's about to talk. So he opens the mouth like this, and then duplicate again, make the next costume. So this is when you actually, and somebody like JC knows how to draw very well. So JC can make cartoons better than I can, because, right,
Give me, he knows how to.
he knows how to
He's
draw.
better than me.
So once you come here, that's all. You see, he's talking. Or he's eating something, yeah? He's talking. Then if you also want to change the eyes, it's also good, so that at least when you are talking, it's like your eyes are not just one type of eye. You come to your costume and you click on this eye, and then you can decide to flip it, flip the eye, and now it's different. It's looking up. You click on this one, so you flip it, then it's also different. So now if you go to code and you do change costume, at least the eyes too are changing. You see that eye is winking as he's talking. He's switching one eye. So at least when you look at it, you like it, because it will look better than if he was not switching the eye. Okay, so and if he wants to wink, then you can also make him to just wink by the eye and not like the one that the eyes wink, like this one. Duplicate this one, and then switch the eye again. Let me see. And then this other one, the eye is down. Good. And then this one now I delete. And this one I delete again. So now if we are going only with these two, you see that it will just be like winking. You see? He's just winking his eyes. So in some areas of your cartoon, the character is just winking the eyes. In some areas, the character is talking. So, but what if I bring back all the other ones? I put them there. Then instead of just using next costume, you'll be using like switch, and you choose the costume that you want to do that one. But if you have like 10, you can put 1,000 costumes, and they all have names. You can even just name them 1, 2, 3, 4, 5. Or you can instead switch by costume number. You can switch by costume number. Is there? You can put it inside here. So switch costume number. We are switching by the numbers. But now in this number, when you say number, so now it's not switching. This number, you have to switch costume. Yeah, this one actually switch the costumes. Right. Oh, switch to costume 2. Next costume. You have to go back and say switch to costume 4. And switch to costume 4 and that. And then if you give it a number, switch to costume, then you come here and put a variable for number. Then change costume number. Change costume number. Do we have a code like that? Well, anyway, when you go to next costume, the number is there, and say switch costume number. You go to next costume, number is there. You go to next costume, the number is there. Well, all these ones. Let me first gather my train of thoughts before I can add any new thing. So for now, we have seen all this. Your costume adds another element to your understanding of what the properties of sprites are. So we are learning properties. The last one that can really be so cute For example, T is here. I can come to T here and I add a costume. I go and click here, choose a costume, and I say the T costume is this girl. Now I want you to see that. I want you to see that costume does not mean that. So now let's show this T. Where's the T? Oh, this is T. So let's show the T and let's hide this one. You hide. So now if I say next costume, the girl is here. Now the girl is a T. Oh. Oh. It's here. So the girl is here. Now the girl is a T. Now it's a girl. Now it's a T. Now it's a girl. So with this costume again, it's not like costume must just look T, but different types of T. No, costume can be so many things. So you can use like when you say, hey, a monkey can change into a giraffe and then changes back to David. And then David can change into Angel change. And then here you can also put your pictures. How do you put your pictures? You come here and you go to upload and you search there, computer, to where you have saved your picture. For example, this one, I bring it and it's here. You see? So in Scratch, you can also go and bring your picture. So take a good picture of yourself.
What?
And you can crop it. And then when you bring your picture like this, and you only want this phone, you don't want everything, we go to costume, and then we can now crop
I'm gonna
it.
leave that background.
You can erase, convert back to vector. Vector eraser is better. But now we have to make it to look like this first. And then erase. You see, when you erase all these parts, this eraser, it has the size, it says 40. You can increase this size to, let's say, 100. So that it becomes very big. It's easy to erase.
Did you get that?
Is that Daniela?
No, it's Dylan. Mr. Dylan's hair in the video.
So when you
I can
erase,
subscribe this video.
hey, convert to bitmap. Let's erase under bitmap. Yes, these erasures are nice ones. Then delete is no more. Select. Delete is no more. Select like that. Delete is no more.
What?
No more. So now on stage now it's just like this. So if you keep deleting, you can make it nice until it's just what you want to see. Yes, of course you can make it larger so that it's easy for you to go and walk other parts.
I have one question.
Yeah. Yeah.
How do you put?
You can also select and feel. You know, feel goes and feel nothing because it says nothing. So you can go and feel nothing somewhere, you know. So when you feel to, you can use feel to erase things. You can just go and feel them with nothing. So that's what we use. So now, if you spend your time, you can make it to be perfect. So you can also bring your own picture here and you crop all around your picture and just enjoy that standing. Maybe that's looking like that. This is.
No.
So that will bring us to the end of our first thing was Sprite. We have looked at Sprite. Let's resume. For Sprite, we say we have a Sprite and we have properties of sprites. And where do we find the properties of sprites? We find them here at the, what do we call this? Property pane. The property pane. If you were repeating, at least your mouth will remember it. Since you never repeated when I said pane, you are looking at it, it's not coming. Because you thought like you put too much confidence in your own brain. When the teacher is telling you that when you repeat with your mouth, you give yourself a better chance at remembering things. You think like I'm joking, I should be repeating myself to you. So, and then here, below here, we have so we have the menu. This is the menu. When you bring a new sprite, the new sprites will come here on this menu. So if you want to program for any sprite, you first have to select them on the menu. Like when you want to eat food, you select the food in the restaurant. If you want to program N, and the shadow of N will appear here. If you want to program this letter T, it will appear here. And you know that it is letter T because that's just a costume of letter T. It's called block T. If you change it to the next, the name is still block T, even though it's a girl now, the name is still block T. So we have seen properties here. We have seen position. We've seen left, right position is X. Up, down position is Y. We have seen direction, which means turns or angle. We have seen size. We have seen transparency. We can show, we can hide. And we have seen the name, right?
Yes,
we have seen what?
The name.
And then the other properties of sprites that we could not find here at the property pane, where could we find them? We find them under looks. And we saw a lot of them under this change. When we click down here, other properties are like what? Color, fisheye, whirl, pixelate, mosaic, brightness, and ghost. Very good. So we've seen all that. Now, there's another property before we leave. It's called front or back. Now, let me put this thing. See? Who is at the back? Who is at the front?
The girl is at the back and the phone is at the front.
Good. So can we change all that? Yes. We can come here. It's called layer. It's called what? Layer. Now we layer. So layer means like when you open a book, you have pages. Layer means pages of a book. Imagine the book pages are transparent. If your book's pages, you can see through the pages of your book. That's what we call layers. And here in Scratch, they have so many layers like that. So that's why you see this one is on the front layer, so it will cover the other one on the back layer. So if you say go to there, we change to back. If we click, see where the phone will go now. Click. Phone is where? Back layer. So sometimes in a game, we can use this one to show what? Hide and seek. Hide and seek. So now when we click the girl and we bring the girl to 50%, okay. Now if we go now to the phone and we say, hey, come to the front layer, what will happen to the girl? Hide. And go to the back layer, seek. Hide and seek. So the girl hid and now the girl is here. So using layers can make your game to be so good. And what is at the last layer is called your backdrop. When we click, we see backdrop here. Backdrop is the last layer. So every other thing is appearing on the backdrop. So if we say, who is here coming to the front layer, come to the front layer. If we switch, we'll see the girl behind. So no layer is farther than the backdrop. So the backdrop is the last layer. Everything is in front of the backdrop. And before you meet the backdrop, you can add several layers. You want to add 100 layers, you put 100 up there. So again, that is a complete overview. If we are missing anything, we have talked about layers. Very good. And we have show, or we can also do this show here and hide. We can do show, we can hide it. Hide, the phone is not there. Show, the phone is there. Hide. So, or we can just use it here. Show, hide, show, hide. The ones we start to program, these are the ones that we're going to be using. We're using the code. Because you want to go full screen. You don't want to come there and be touching the pane. The pane is no more there. We'll be here. So we do that. Like press the keyboard, up arrow to hide, down arrow to show. So there we can just say, hey, go to events and say when up arrow is clicked, we change it to what? Up arrow. When up arrow is clicked, you show. And we come here, we say when down arrow is clicked, you hide. So there we go down arrow. So if you go full screen now, you can now be using now and be controlling. Show, hide, show, hide, show. Playing the game, playing your game, you're showing your hide. Because now it's control, how to control your events from your input devices, either from your mouse click. If I click the mouse on this girl, so this girl disappear. We'll look at all this when we learn code. And today we are just doing the what? Sprites. And the different properties. The different what? Properties. So we've come to the end of the class here. It was a 2 hours class already. Oh my God, I didn't want this class to go out to 2 hours. It's a long format class, 2 hours. That's the time there, 1 hour, 53 minutes and over 30 something seconds. So after this class, we are going to C programming because Dylan is in the class. So students who are learning C programming will stay, and we have a class with Dylan. D-boy, are you there? D-boy, you are muted. I can't see you.
Yes.
All right, make sure you have your W3 school is on, and everybody say hello to Dylan.
Hello, Dylan.
And Glory, goodbye to Glory. So Dylan, I'm gonna end this class because I want to save the recording that we just did, and then we're gonna come back 2 minutes later, 2 to 5 minutes later. Okay. So open your W3 schools and go to function, making your own function. Open your W3 schools and go to making your own function very quickly. Okay. Yeah. So and you come back on in about 2 to 3 minutes. All right. So see you very soon. Very, very soon.